Hello everyone, this is Jan Harris, and today I would like to talk to you about responsive grid containers, and more specifically, how to build those responsive grid containers based on your product requirements. I'm sure most of you have experience working with CSS media queries. However, we're also going to review a use case where it actually makes more sense to rely on CSS container queries instead. So let's dive right into it. I have spent a little bit of time and built this very basic interface where we have an undefined number of cards as well as the left side panel. And this left side panel actually has some sort of arbitrary menu, and it expands as well as collapses. We are going to ignore this left side panel for a little bit and going to focus on our card layout first. So the two files that I'm going to be touching for the most part are the custom grid and the custom grid item. Despite the name of those files, I'm actually going to be relying on display flex for the grid container, but I will likely go back to this exercise and try to recreate my behavior with a display grid instead. Before we dive deeper, let me give you a little bit of an insight why I'm starting with a flex. First and foremost, I actually have a requirement on my end to be able to define the size of each grid item or grid element individually per each grid item. An approach that I'm following is I actually define the number of columns I'm going to assign to this grid item based on a screen size. Those screen sizes are available to me in the form of props. So for extra small screen, I define the number of columns. For medium screen, I define a number of columns. For the large screen, I define a different number of columns. And I also have access to a small screen as well. So what that allows me to do is I can now define my grid wrapper only one time. And based on different conditions, my grid items can take up different space based on the role, the type of data I'm presenting, or any other condition that matters to me. Over here, you see that I have featured mock data and I have regular mock data here as well. So for the featured mock data, I actually say that it's going to take more space on the large screen comparing to the regular data. And if we make an assumption that in total we're going to rely on a 12-column grid, this means that for a regular item, I will want to see a 3-column layout, while for the featured item, I want to see a 2-column layout. This in my mind is a really great way for me to control how my grid items are being presented without having to have a closely tied relationship between the grid container itself and each individual grid item. This is where display grid seems to be a less obvious choice to go forward with. One of the main reasons is that if I would like to define grid template column for my container, I actually have to do it on the container level. I can certainly still achieve this result with the grid layout by allowing individual items to span multiple columns. However, let's just start with the display flex, see what we can get here, and then in the next video, we can review this same problem with the display grid. As you can see here, as I am resizing my container, I actually don't see any changes happening. The reason for it is that I don't yet have the CSS written for different media queries. So let's go and take a look at what the custom grid looks like right now. This is very bare bones. I'm starting with React with TypeScript, as well as relying on Emotion for any styling. Over here in the custom grid container, the only prop that I'm accepting currently is spacing, as well as children, of course. And if spacing is not passed through, then I have the default spacing of 16 pixels. So as you can see, I have minimal style in here. All I have is a gap, the display flex, and allowing it to wrap. Now, let's go into the custom grid item. The custom grid item component is where the magic happens. This is where I define my breakpoints, as well as pass along the column sizes per each individual breakpoint. Within the style, however, I currently don't have the logic that I need. So this is where we can get started. I have a default width that I assign to every single card. I'm taking a mobile first approach, which means I am defining the smallest screen size rule first, and then I'm going to go and assign the larger size rules. As you can see, I don't have a media query here, but the way you can read this is min width of 0 pixels will have the following rule assigned to it. I'm going to be honest, I use ChatGPT Canvas to help me create this basic layout. I'm also relying on material UI components. And this is what I get from ChatGPT 4.0 in Canvas mode. It tells me that it will take the number of columns that are passed through for extra small screen size, and it will divide it by 12 and multiply by 100%. However, if I'm not passing any extra small size columns, then it will actually assign a single column to it and then divide by 12. And let's see what happens if I don't pass the extra small. Instead, let's rename it to small, and we see that it actually divided the entire width of this container into 12 parts and only lets these cards have a single column width. This is actually not the behavior that I want. I want the default behavior to take an entire width, which means take the 12 columns right away. This is what I'm going to fix about it. Now let's start writing our media queries. I'm going to rely on my breakpoints. So now that we have 100% width assigned to every grid item by default, we need to start building on top of it. This math doesn't really change much. So let's go ahead and copy paste it for other breakpoints. Medium, large. So we are currently looking at the medium breakpoint. We're going to have to inspect the source. Let's make sure we are still in a medium breakpoint. And this is our grid container. If you look at the styles, you can see that we have a gap of 16 pixels. Now, looking at each individual card, the width of each card is being calculated to be 50%, which sounds correct. And with flex wrap, it should actually have 2 items in each row, but it currently has a single column. So why is this happening? It's actually happening because of the grid gap. If you have 2 times by 50% plus another 16 pixels, the overall width of the container should be 100% plus 16 pixels to fit 2 cards at the same time. We're not going to do any negative margin tricks. Instead, we're going to do a little bit more math so that we can calculate an appropriate width for each card, taking into consideration the gap. So I'm actually going to go back into the custom grid container and I'm going to create a context. This context we will be able to pass through to each individual grid item. Let's say const create context, and it's just going to be gap number of type member. Let's create a custom hook for our grid items to be able to easily get this grid value. Export const use container grid. Gonna say use context and use the context we have just created. We need to remember that we have to set gap to something. So we're going to set it to undefined. So now within the grid container, we're going to add the context provider. While we do have spacing available in the props, we're actually not currently using it. So let's expand this, pass spacing along here, as well as... So this clearly doesn't work. And the reason it doesn't work is because spacing actually is a number, and what we need is pixels. So I'm going to take pixels out of here, and I'm going to put it over here. And now, as we were passing 16 to spacing anyways, we have our spacing back. Now, how can we use this grid gap in our each individual grid item? Let's go ahead and import this grid gap from our context. We're going to go ahead and add one more prop to the styled grid item, and it's going to be the gap. We're going to pass this gap from our context. One thing to keep in mind is you actually need to divide the gap and only subtract a portion of a gap from each column width. Let's take a 2-column grid as an example. In a 2-column grid, you have 2 cards, each taking about 50% of the width, but you also have a space or a gap in between. So for 2-column layout, you actually have to take into consideration only 1 gap. Now, if you think about a 3-column layout, you actually have 3 columns, each taking about 33%, but you have 2 gaps in between. So this is how you get the multiplier for the gap. You actually need to take the number of columns in your layout and you need to subtract 1. For a 2-column layout, the multiplier is 1. For a 3-column layout, the multiplier is 2, and so on and so forth. This means for a 2-column layout, we need to multiply the gap by the multiplier. It's going to be 16. For a 3-column layout, it's going to be 32. Now we need to take this number and we need to divide it by the number of columns. So if we have a 2-column layout and the gap of 16, we divide 16 by 2 and we get 8. That means we need to subtract 8 pixels from each column to be able to fit it in 100% width. This is how we do it in our media queries. We actually have to wrap it in a calc. I think I'm going to write a custom function to make this work. For the width calculator, I'm going to need the following things. I'm going to need columns for the number of columns. And again, I'm going to need the gap. So let's calculate the number of pixels that we will need to subtract from every column based on the number of columns and the gap. Let's call it subtract. As I said, we need to multiply the gap by the number of columns minus 1. Now, whatever we got, we need to divide it by the number of columns. And that's the amount we need to subtract from each column width. In the return statement, we're going to say the following. Width columns or 12 divided by 12 multiplied by 100%. So that's what we had originally. This is just a copy of every single width statement that we have below. However, for subtracting, we're going to need to use calc. So however many percent we get here, 100, 50, 33, we're going to subtract the amount we calculated earlier, add pixels, and close the bracket. So now let's go ahead and use this width calculator. So now that we have the width calculator function available, you see that both columns and the gap are required in this function. However, for both the column size as well as the gap, we might end up with an undefined value. So my suggestion is to simply make an assumption of what you would like to be the default value over here. And let's go ahead and copy paste this for any other media query. Do not forget to change the prop that you're passing based on the media query. And you can see that from one column, we switched to 2 columns. So we switched to 3 columns at the bottom and the 2 columns at the top, exactly as we had defined it in our app.tsx file. So this is working as expected. However, this is the point in time where I would like to go back to my left panel. My left panel is medium-sized panel. There could be situations that I might have content that will actually stretch it out or make it wider. It could be that the design team will require it to be wider than this. As you can see, every time I open this left panel, I actually squish the container size where I have my cards present. I don't have a lot of functionality or content present in each card, but you can imagine that each card might have a series of buttons and additional functionality requiring the minimum amount of width in pixels to be able to fit all this functionality. So now the media query is only responding to the screen size changes. However, as we open the left pane, we're actually changing the size of the container or the grid container that is holding all these cards. So as a next step, I'm going to go ahead and actually replace the media queries with container query instead. Before I do that, I anticipate there are going to be some questions around the overall support of the container query in the modern browsers. And as I've been searching for a grid library in React that would do exactly this, but based on the container query, I had found numerous ones. However, they all actually relied on JavaScript and on resize observer instead of having this all written in pure CSS. So let's go ahead and look at the Can I Use website. So now for the container queries, I'm going to zoom it up a little bit for us. It really depends on what product you're working on. So Internet Explorer, most likely Internet Explorer is still present in some systems, but I would anticipate it's probably present in a really strictly locked systems that are used by high security IT teams that are still on Windows 7 or Windows 10 and haven't gotten a chance to upgrade to the Edge browser that is based on Chromium. So if you think that there is still some usage in your customer base that is relying on Internet Explorer, you definitely are going to need a fallback or a polyfill. However, as you can see, a new version of Internet Explorer has not been released in over 12 years, and the global population that's still using this browser is less than 1%. QQ browser, well, this one actually has potentially substantial use. My guess is maybe population from China is relying on this. It has been released in 2024, so it's still pretty current, however, clearly lacking support of some of the features. So a few users are based in China. There could be some folks that are relying on this browser, so make sure you keep that in mind and have a fallback. For everybody else, Chrome, Edge, Safari, Firefox, Opera, Safari on iOS, Samsung Internet, Opera Mobile, Android browser, Firefox for Android, all of these modern versions support container query out of the box. And if you're looking at the large 4 or even 5, which is Chrome, Edge, Safari, Firefox, and Opera, they actually have been supporting this feature since 2022, all of them, except for Firefox. 1.5 to 2 years of all of these browsers successfully supporting container query and CSS natively without polyfills or fallbacks. So in my book, this is where my primary customers are, and I'm going to feel pretty safe writing container queries without having to worry about the fallback. Let's go back to our code editor. So first step that I'm going to take, and I'm actually going to rename all the media queries into container. But this is not going to be enough. I need to go back to the custom grid wrapper first. Let's go into Mozilla documentation and just take a look at the container queries real quick. So the syntax is super similar to the media query. You can define your condition in a lot of different ways. Max width, min width, width greater than. You can rely on ENs, percentage, anything that makes sense to you. However, for your rule to actually start working, you need to define container type. I'm going to take container type inline size. So what inline size means is it's going to respond to changes in the container width. So when it say inline, it's going to start looking at how the container width is changing and then go back and look at your container queries. And this is exactly what I need. One more thing to keep in mind is inside of the container query, there are some things that are optional, some things that are required. First thing that is optional is actually defining the container name and then referring to this name in the container query. I think it adds a little bit of clarity and adds a little bit of cleanliness to your code. So I actually would recommend to do this so that you can always have a visual indicator in your code of what this container query is referring to. I'm going to add a container name to my grid, and I'm simply going to call it grid. Now to each of my container queries, I'm actually going to add the container name next to the query. This way I know that this rule is applying to anything that appears inside of the grid container. Now, one more thing. I'm actually going to go and add a class name to my styled grid item. And it's simply going to be grid item. Inside of each of my container queries, I'm going to reference this class name and wrap the curly braces around each width. One more thing I'm going to do is I'm actually going to add the reference to my original emotion style name. So this means when my emotion generated style name appears right next to the grid item, all these rules are going to be applied. Let's save it, and bloop, as we resize it, we're going to see the 2-column layout and the 3-column layout accordingly. So let's just stick right here. This is where we have a 3-column layout, but we are right on the edge between this 2-column layout and the 3-column layout. Remember, this is different from media queries. We are actually relying on the container size that wraps around all those cards. Let me open my left pane. As soon as I open my left pane, the container width actually collapses and became less than my large breakpoint. This means that the layout automatically responded to the change of this container width, and now we are relying on the 2-column layout so that in the smaller width of my container, I am still able to fit all the important elements that are present in each of the card without having to wrap them extensively or without having to deal with an overflow. So my message to you guys is do not be afraid to use container queries. I absolutely love them. I have just implemented container query-based grid into my recent project. I absolutely think that you should be thinking about progressive web development and meeting the needs of the population that has more advanced browsers and more advanced browser feature support. And if you still have some of those strugglers, they're lagging a little bit behind and using some of those older browsers, feel free to add a fallback with a media query. It will be a little bit less responsive with this expanded left panel. However, it will still meet your fundamental need for responsive layout. Well, thank you for watching. I hope you will give container query a try and let me know what your experience has been. Until the next time.